thank you for having me. I'm really excited to be part of the conference, and we met with Boris a long time ago in Ukraine, so I'm thankful to him to know him from there. Yeah, so I will share my screen now.
Yes, please.
I'm not really a slideshow guy, so most of the time I will prefer to show you directly code. And during my presentations, part of, when the book was released, like last year, I did something like a world tour of presenting around the world. And usually, because because of the time on conference and talks, it's different. I prefer every time to show different stuff, and I prefer to stick to the more of a production-like environment and give you like really working solutions that we use in our projects. So I will skip the theory. I will try to explain it with examples. I saw that actually tomorrow there is a speaker who will talk about API testing. And right now I'm part of a new project where we need to automate microservices, APIs, IoT, etc. And we need to test APIs. And actually the book is more related to UI automation and web. However, many of the patterns, they can be applied to no matter whether it's desktop or UI or API. So right now I'm going to show you two of the things that I started working on. Here I have one simple API. Actually, it is part of my, on the new book that I'm working on, because it will have a part for API testing. And just here, I wanted to show you simply what does this test API does. It's like a music shop API that we have tracks, authors, albums, etc. It isn't that important, but basically you can do all kinds of CRUD operations. CRUD means create, update, delete, etc. And when you provide here through the URL the ID, you can get in a JSON format the information about the thing that you want to get the information about, right? And I'm just showing you Postman because many people are comfortable with it, and we're doing like manual testing with it mainly. And when we are talking about Java, of course, tomorrow there will be a talk, maybe much more in deep about REST assured. And yeah, this is basically the main API to go when we are talking about Java. Before talking about design patterns, I want to mention something. What is actually the design pattern? The design pattern is something like a general solution to a particular programming problem in order to achieve different things. And in my book, I separated the design patterns based on the things that we can get in the test. For example, maintainability, API usability, and so forth. There are many different attributes, right? So you can apply one pattern. For example, in UI testing, we're going to talk about page objects, page object model. This is one of the most famous patterns. You can, depending on the context and what you want to achieve, you can basically modify the pattern to fit your needs based on your context. And I'm going to explain this with the API context as well. So here in the REST assured code, basically we can provide authorization headers. This is here my API, test API that I developed is using OAuth2 to authorize, basically to give me access to the API. And another thing that I sometimes need to mention is you need to provide the header that you need to return JSON, or there is a specific method here in Java. Again, this is not really important because I'm not going to teach you, rest assured. But just in short, I want to explain what my idea is. And actually, APIs are really, really important in modern web automation. Again, tomorrow there will be a special lecture about it. However, keep in mind that in order to build maintainable tests, half of your job is actually to prepare the test data. No matter whether you're going to test API, mobile, or web. This means that, for example, if you want to test a shopping cart and you need a user, probably you're going to create the user using some of the APIs, right? In all of our enterprise projects, we are doing exactly this, no matter whether this is API, mobile, or web. And this is the thing that I'm going to do in this particular project as well. Of course, I'm not going to show you production code. I'm just going to show you this demo app. But yeah, basically, even here below, in order to test the delete for the API, this means that first I need to insert some data, right, in order to be able to execute the test in parallel. Otherwise, if we have one continuous job, then other developers are running the test as well with static data. Many of these operations, we cannot test them, right? And this is one of the core things that we need to accomplish in test automation to make our tests, one test to be not dependent on other tests and on a static data. If this is possible, because there are contexts that this is not possible and we can find workarounds, but still. So one of the first patterns that I want to show you is actually, instead of, because in rest assured, you can work directly with the JSON, like in Postman, right? You can check directly only, for example, that here the title is particularly this. And if we have many nested JSON pieces here, you can do that as well. However, my preferred approach is always to deserialize and serialize the data back and forth, depending on the language, to Java or C# objects. We usually call these models. And so if this is one of my albums, I can deserialize this to a Java object. So I can show you here the album. And there is this Java representation of this simple JSON, right? We have the variables, we have the getters, we have the setters. You don't need to, write this yourself because you can copy this, and then there is a website here that can generate this for you. There are many other websites similar tools. When you click generate, it will generate this. It's called Pojo Object. Basically, this is just an object that we are going to use it as a holder of the data. And later, even without any design patterns, you can, in the rest assured, you can cast basically the, for example, here I can get, when I call the genres URL, my API will return a list of genres, right? And it will deserialize them to a list, and then I'm going to work with my Java objects instead of working with text or JSON. However, again, in order to ease the work of my team, we were thinking about working with two design patterns. One of them is called a repository. And the job for the repository is that maybe some of you that have more of a dev background know that we usually use database repositories for accessing the database. And there we can do simple operations like, again, get, update, delete, create, in database context, insert. And this is called a database repository. And many frameworks such as Entity Framework and others are doing exactly this for you. You don't need to implement it yourself. However, it's possible to create repositories for HTTP requests as well to hide some complexities instead of copy pasting these long pieces of code with rest assured everywhere. We're going to have one repository. It really depends on the implementation because you can create it much more generic. Actually, this is the thing that I did. I actually created one generic HTTP repository here. As you can see, generic is where I just provide here, instead of T entity, which stands for type entity, I'm going to provide one of my model classes. And then this abstract base class will help me. As you can see, I defined one get by ID method where just is going to call my API with the authorization token, and it will return the T entity. But I made it abstract. This means that I'm going to reuse it for all of my models here. And later on, here I also provided other methods such as put, which will update my entity in through the API into the database. We can delete it, we can create one, we can get all of them in, even here use the stream API, which allows me to filter the data. And the usage is quite simple. I just write this once, and then for each particular model, I just extend this base repository, put here the actual model class instead of T entity, and then I get all of these methods for free, right? And I can use them in my code, no matter whether I'm testing APIs, mobile, web. I can use these repositories to create, arrange the data. Again, this, by the way, you can apply this directly if you have to work with databases. This is completely fine. Instead of calling REST assured, you're going to call your database engine, depending on the library and the language that you use. It's the same thing for JavaScript, C#, Kotlin, whatever, is the same design pattern. And now when we need to build the data itself, like for example, even for this simple test API, we need somehow to create the actual model classes, actually the data that we're going to insert or update, whatever. And for this particular job, we use another pattern. It's called factory design pattern, from producing stuff, right? Maybe we are using it in the most straightforward way. It's just a class that calls methods that can create data based on particular parameters. For example, here in this simplest form, I'm just creating unique genre of music, and I'm using a library called Faker. This is a famous Java library for generating random data. So here I'm just generating a random title. Many often here we are going to generate timestamps, current dates, whatever. Perfectly, I prefer not to couple my factories with the repositories, and usually I prefer to separate them. Here, on purpose, I put this here just to show my team to discuss this approach, that I prefer here only to create the actual models with the particular data. And then on a second line, I will just call the repository and provide the data there to create the object. Instead of doing it with one line, I'm going to do it with 2 lines of code. But then we can reuse this factory for actually creating, to use it also for creating expected results, because many often you don't need only to generate the data to put it into the API or into the database, but also you're generating some data for, later on using it to assert the actual content of your API or website, whatever. So yeah, this is one thing. Again, as I said, we can use this for web and API as well. There are more advanced patterns for so-called creational design patterns. One of them, it's called builder, and it's related and it's used in cases where, for example, in order to create one entity, one model class, and it depends on the data for 5 others, the builder can help us to, I don't have the code to show you, but I found an article that just has a example of such. The builder, this is called Fluent Builder. Actually, in Selenium, we have similar classes. If you have experience with WebDriver, there we have this actions API for performing drag and drop and other more advanced actions. And it's actually implementing builder design pattern. And in builder, again, it's more complicated and I won't have the time to explain it. I just wanted to just write it down and later you can research it. But in cases where you have interconnected models that you need to create, we can use the builder to with this to configure the different data, right? And now, if we need to focus more on UI testing side, I have a demo website that I usually demonstrate the different design patterns. Again, the design patterns can help us to make our code much more readable. And through the book, I was explaining that even the most simple design pattern, the page object model design pattern, just shortly, I will explain what this is for those of you that don't know. The whole idea of the Selenium testing, if we see one simple Selenium test here, I automated this shopping cart with the simplest and dumbest way to implement it with hard-coded pauses. Don't do that. So here I just have one huge test. Don't write it like this. This is the first before applying any design patterns, but this is Selenium Webdriver. Here, initially, I'm downloading the correct driver for Chrome. Then I'm starting the Chrome browser. Then I'm navigating to my page, and we use the find element to locate different elements. We are clicking on them and so forth on the different pages. Here, I'm performing actions on 3 separate pages. So I'm adding here a rocket. Then I'm going to the cart. I'm applying a coupon, increasing the quantity, etc. Right? And the whole point of the page object model is that we have one file. It's called a map, where we put how we locate the elements. Then we have, you can put them in one file if you want. This is actually the original pattern. In this page object model, we're putting all the actions that we can perform on this particular page, how we locate the elements, and it's a matter of preference whether we put there the assertions. I prefer to do that. So this is one way how you can implement it. But the thing that I wanted to say is that depending what you want to achieve, through the book, I showed 10 different variations of this particular simple design pattern, right? Maybe I can show you one implementation of this. So here, this is the main page, and the main page that I showed you of this demo app. And as private fields, I expose the different, as private methods, private getters, I expose the different elements that we find on this particular main page. And then we have like public methods, all the actions that I can do, and probably assertions. This is the simplest way how you implement, how you can implement this. Of course, you can create a base page for example, many often we have repeating elements and actions that you can do on several pages. For example, On all of the pages, I have the menu, I have the footer, I have this search, I have here the shopping cart section here, right? Also, there are some parts that are specific and repeating only on a few particular pages, like this breadcrumb or the second navigation. So one way how you can solve this, instead of copy pasting, you know, for example, these are the links that are repeating on every page. One way, which is not great, is just to copy paste them around. But this means that if you need to change later the locator, the name or whatever, you need to do that everywhere, and this is not good. Another way how usually people approach it is to create a base page and put everything that it's common to different pages in one base class. However, this is not perfect as well, because as I said, for example, the breadcrumb, the secondary navigation, it is visible only on 2 of 4 of my pages on this demo app. And this is breaking the object-oriented design, right? Because the base page and the base class, it should contain only the methods and the getters and variables only common to all of the child class. Otherwise, you're breaking the OOP design principles. So another design that you can use is actually, we can abstract and move all of the logics that are common only for particular sections. And I usually call this a section. For example, this is menu section, this is search section, this is online shopping cart section, footer section, etc. And instead, we can use composition to, what is the composition? Composition means that we're using these mini page objects as variables and as getters as part of the page object, instead of deriving them from the base page or the base class. And here I did exactly this. I separated all of this common logic to different sections, right? And I move only the logic for the main menu. These are the main menu items here. I'm searching for them every time. And then all of the actions that I can do for them. Is the same thing for the search. For the search, I have only the search field, and I have search for item public method. And then if I need to use them, I can just use them here as public getters. And then, yeah, of course, I will have to create these getters and every time create new, but this is perfectly fine. On a training recently that I led like 2 weeks ago, in one of the projects, they asked me how actually, when you create all of these, you know, page objects, all of them, how you create them, how do you use them in tests? Do you create them every time with the new keyword, or what do you do? And now I'm going to show you something related to the factories that I showed you, but it's something a little bit different. I prefer to call this app design pattern, and this app class, actually it's responsible for, it's something like a factory, but actually this is a factory method for creating page objects. And if we check the test here, instead of, again, as I said, creating here the page objects everywhere in every class, like private variables, then using them like this, instead, because many often it depends on the complexity of your library or framework, these pages can contain many more dependencies, and it won't be easy for you to create them just with passing the driver, right? In many enterprise projects, this is the case. And for example, in our enterprise projects for the C#, we're using inversion of control container, which is beyond the scope of this lecture. But the simple way how you can, again, one way you can do it is just every time to create it with new. But if we use the app design pattern that I mentioned, is that we can create this app. It can be even put in a base class that it's common to all of our tests, and we can expose it as a getter. This is actually how we use it in our framework. And this app design pattern, actually, it holds reference to all the different, so to say, services that we use, not only to the driver, not only to for holding these factory methods for creating pages, but also, for example, it's through it you can access the different HTTP repositories, factories, etc. It's like a common place for accessing all the different stuff from the framework. And through it, again, I have this go to and just create methods that, again, this is called factory method. Don't confuse it with factory class. These are two separate design patterns. But with the factory method, it's actually when we provide the class that we want to create. Again, in Java, I don't really like the reflection, because really Java is like a few years behind C# and other modern languages. It's like a design flow from the beginning, and it's a little bit more complicated to write reflection code. Through reflection code, actually, runtime, we can create objects, we can get their annotations, we get their methods, etc. Many often we use reflection for creating tools and more hardcore development tools, right? And especially if you are a more senior person and you are working on your custom frameworks, for sure, probably in your career, you use a lot of reflection. And this is what I'm doing here. Instead of, when I have a new page and create a new getter somewhere, instead of editing my code every time, because in many production projects, we have tens of thousands of page objects, many of them. They are huge. So we don't want to have these huge files with many page objects. This is why through this class, again, I have just two methods that through reflection, they are creating instances of my page objects. Even here, I'm through more reflection, and I'm applying another design pattern. It's called singleton. But again, I'll just keep it simple and not talk about it. But basically, singleton means that you have just a single instance for the whole run. It's not static, because we use singletons in places where we need to use base classes and derive from their logic. But actually, through the singletons, they allow us to have a single instance. And many often, actually, page object models, they are perfect to be singletons, because they really don't hold any data, right? Like our models. We don't need to have, they don't have a state. So yeah, this is one of the patterns. Another, maybe we have like 5 minutes. Maybe one last pattern that I can show you. It's called Facade. And actually this is something similar to the factories that I explained to the builder. Because when we have many pages, like here, we have a workflow, and the workflow here is that I add an item or two items, then I change the quantity here, I update the cart, then I check some prices here, then I proceed to checkout, I fill all of the information here in the billing, etc., and then I complete the order. And this is my test, right? This is a huge workflow where we have a combination between 3 to 4 pages. Of course, we can always design the test in a way that I skip part of the pages while setting all of the data before that through the API or database and open this page directly. This is completely fine and you can do it. But again, this requires a lot of data setup that some of the projects, you cannot achieve this early on. And this is why, in order to achieve this huge workflows, we can use another pattern. It's called Facade. Basically, the Facade, you can think of it as a wrapper, as a workflow. Maybe the classic implementation again here, I just explained it with this for 3-4 pages. I created this purchase facade. The purchase facade is actually a class that holds the whole workflow, and I have a single method for creating one purchase. It's up to you whether to put the assertions here, but basically we're pasting as and providing as dependencies here the different pages, and then we are creating the whole workflow, opening the page, adding the cart, whatever, and we're abstracting all of it through parameters, how many products to add, which products we should add, what is the coupon that or the discount that I need to apply, what is the quantity, what is the expected price. It can get really complicated and really huge, so you need to be careful because you don't want to create like a development logic in your test framework where you need to write a test for it, right, with many conditions. So I really prefer to complicate things when it's needed, right? You don't need to apply all of these complex design patterns at the beginning. You need to do it step by step, but you need to consider that at some point probably you need to do it. This is why in my new project that I'm starting working on now, I explained to the other architect from the other side that I want to start simple with just these simple factories for creating the data. And later on, if we see that there are many interconnections between the data, then at this point, we're going to apply the builder design pattern. And it's the same for the singletons, facades, whatever. And if we need to see this in action here, what is the difference between this is the same test without the facade. This means that probably if you apply all the test case design techniques and whatever, and even in the simplest form, if you need to write tests for this shopping cart, probably you'll end up with at least 100 tests with the different variations of the test data. And this means that every time, if you don't apply patterns, you have to repeat this every time with different data. Which is a problem because over time I worked on these huge projects where we need to change the workflow. For example, at some point 3 years later, they applied the new discount and we need to change all of the tests. And if you copy paste this 100 times, it's a problem. However, here is with the facade, I am just initializing the data up front, use HTTP factories, whatever, and then just call the facade. If I need to change the workflow, I change it only here. However, this might be a problem. For example, if you extend the the workflow here in this workflow method, you can cause a regression bug in your test framework, and this happens, and it's possible. Yeah, maybe now it's time to answer for some questions because we don't have time to continue showing you patterns. Regarding the presentation and the project, you can access all of them. It's completely available on GitHub. Design patterns for high quality automated test Java edition. Even if you don't have the book, it's completely open source, and all of this stuff that I'm showing you, they're completely open source, all of them. I just mentioned just a few of them. Of course, this about the API, probably I will release it later on and I will create an article about it. Right now, this is like a private project, so I cannot release it. And there was this initial question about the factory pattern. Could it be a hybrid build, or do we need to smash the project? What do you think about that? To be honest, I don't really understand the question. Maybe you can explain what you mean by hybrid. But in any ways, regarding the design patterns, this is why I started with this. You can, you know, it's up to you how you are going to implement it, because in many ways, patterns are context dependent. And as you saw, if you are asking most of the programmers regarding the repository, probably they didn't hear that you can use it with REST API, right? They use it in the database, but actually you can use all these patterns in the context of test automation and in the context of creating test data. We just use it in our software development lifecycle, right? Because really, for me, test automation is something in between. And actually, in my company, we're always hiring people that are more of a software developers, but then they need to have all of the QA certifications, etc. They need to understand all of this, but mainly they are writing code 100% of the time. So this is software development. I mean, you need to have all of the branches. You need to have all of the code reviews and everything. This is software development, and at least this is my belief.